Greetings again. In the last presentation on systems thinking, we defined systems and systems thinking and described and provided examples of causal models. In this presentation, I will describe a stock and flow methodology that allows a quantitative approach to apply systems models. We will then look at issues of greenhouse gas, carbon dioxide sequestration. Stocks represent an accumulation of something. That something could be a physical substance such as water, arable land, or carbon dioxide in the atmosphere. Flows represent movement of those materials from one place to another. A given system can have multiple types of stocks and flows, some of which may interact with one another. Probably the simplest way to consider stock and flows is with what is called a bathtub model. In the bathtub model, we look at the amount of water in a tub based on how much water is flowing in and how much water is flowing out. While this may seem trivial, even the simplistic accounting of available water can quickly lead to difficult to conceptualize results. Take this example where the tub starts out empty and water is flowing in at a constant rate of 4 gallons per minute. And at a time of 4 minutes, the water starts flowing out and gradually increases as shown. Would you expect that the amount of water in the tub for the next few minutes will show the curved value as shown here? That's the amount of water in the tub as a result of this water coming in and this water leaving. Even a simple model can yield surprisingly, perhaps non-intuitive results. Now look at the next slide. In this one, the water in the bathtub starts at 0, and the rate at which the water enters the tub increases each minute. This is called a ramp for perhaps obvious reasons. The water that is allowed to leave the tub is allowed to leave at a constant 2 gallons per minute. But despite the steady outflow, the amount that remains in the tub increases faster and faster. After 10 minutes, it's at 30 gallons, and it's going to keep going up if things continue as they are. Again, the stock and flow model allows us to see what's going to be left in the bathtub as a result of water flowing in and water flowing out. Now, let's look at an example described in a chapter by Sturman that he wrote in 2012 that addresses greenhouse gases in the atmosphere. In this stock and flow model, we see several stocks on the planet where carbon can be located. These include carbon in the atmosphere, carbon in fossil fuels, carbon in the soil, carbon in the mixed layer of the ocean, carbon in the deeper layer of the ocean, carbon in biomass, and carbon in ocean sediment. The model shows how carbon can move from one stock to another, and it describes delays associated with each of these transitions. In order to run this model, we would need to collect data and show how much carbon moves from one stock to another, how much emissions we produce, and so on. However, on a broader scale, the model provides a framework for integrating these numbers into any analysis, and it provides a platform where the various contributions can be discussed, debated, and quantified. By studying this model, we can also garner perhaps a deeper conceptual understanding of how our consumption of fossil fuels changes the balance of the carbon within the atmosphere. In other words, besides providing quantitative estimates of our role in the carbon cycle, this approach allows another means to educate, communicate, and evaluate the model amongst people who may be able to offer different insights into the processes associated with the cycling of carbon on the Earth. Additional systems models can also address psychological, social, and political factors that are associated with climate change, potentially allowing us to identify leverage points where changes in policy or practice can yield important behavioral adjustments. In terms of addressing issues of sustainability and global warming, this is key. To me and to many others with whom I share a common core belief system, it makes perfect sense that the Earth is warming as a result of human activities, namely the gases that we release into the atmosphere, and that this rather sudden warming is manifested by significant changes in short-term weather patterns. Yet to others who do not share this belief system, this notion may seem abstract, academic, irrelevant, extremely inconvenient, or perhaps contrary to business interests. Some are more concerned with getting enough to eat, paying their rent, or addressing issues of personal addiction. There are also people on the spectrum who are likely to share the belief, but do not want to acknowledge it given the enormity of the implications and the innate, perhaps unconscious fear associated with that. A systems thinking approach underscores not only an understanding of the phenomenon, but it can help us to develop a deeper understanding of the wide array of responses to the issue at hand, underlying concepts in psychology and human behavior that necessarily consider social factors coupled with scientific ones. By applying systems thinking to our mental framework, we not only gain an enhanced appreciation and grasp of the physical issues at hand, but a broader cognizance of the deeper and perhaps more subtle and psychological impacts of these issues. Systems thinking affords us at least the potential for compassion and understanding of the differences in thought and action that will, do, and have existed across multiple individuals and multiple communities, and, when integrated more fully into our behaviors, may provide us additional tools for universal growth and acceptance of diversity of thought. Thank you very much. I hope to have some discussion and comments with many of you during the conference period.